So in this question, we are given three solutions. One is sodium carbonate and two solutions of HCl. One is labeled A and another one is labeled B. In experiment one, what does he do? Rinse a burette with distilled water and then with dilute hydrochloric acid. Okay, why it is necessary? Okay, just think about it. Okay, then
To clean.
uh, yes, first was to uh, clean the burette from inside, and another was to make sure that concentration of HCl remains same. So we will rinse it with hydrochloric acid, and the liquid will be discarded. So rinse the conical flask with distilled water, and never rinse it with base or any other solution, because otherwise the drops of that solution would remain there. Then fill the burette with dilute hydrochloric acid A, because this experiment was carried out with A. Run some of the dilute hydrochloric acid out of the burette so that the level of the dilute hydrochloric acid is on the burette scale as per your requirement, whether up to 0 in burette, you know, you may start with 0 or any other uh, desired quantity. You can start with your initial reading. Okay, so but at least l- level of the liquid, for example, in this case, hydrochloric acid A, it should be either on this graduated part or below it. It should not be there. If liquid is up to there, then you must run some of the acid so that it could be in the range where it is readable. यहाँ पे तो कुछ है ही नहीं, तो इसको रीड क्या करेंगे आप? यहाँ पे कुछ होगा तो यहाँ पे देर आर ग्रेजुएशन मार्किंग्स है यहाँ पर, तो आप उसे मेजर कर सकते हो. ओके, so fill
जी
the burette with dilute hydrochloric acid. Run some of the dilute hydrochloric acid out of the burette so that the level of the dilute hydrochloric acid is on the burette scale. तो burette scale का मतलब ये नहीं है कि वो 0 पर ही है, बस burette scale जहां पर है वहां पर होना चाहिए, ताकि आप इनिशियल रीडिंग को नोट कर सकें. यहाँ पे तो हम कुछ नोट ही नहीं कर सकेंगे. And if you want to watch how titration is carried out, then you can watch my one of the video. I will share the link. Okay. Record the initial burette rating, whatever the initial burette rating. It could be 0, it could be anyone else from the burette scale. Okay. And
जी
then use measuring cylinder. What is measuring cylinder? Measuring cylinder is like this. Okay.
जी
There is a variety of measuring cylinder. So we measure 25 centimeter cube of aqueous sodium carbonate from here. 25 centimeter cube of aqueous sodium carbonate. Okay,
जी
in the conical flask. Means from this bottle, you have measured 25 centimeter cube, and then in the conical flask that is used for titration. Okay, we have taken it
जी
here. And record ये तो हो गया था. Add 5 drops of methyl orange. It is an indicator. Methyl orange. Methyl orange is an indicator. I'm right. I have written it here. MO. And remember that the color of methyl orange in base is yellow. So on adding methyl orange, it becomes yellow. Okay. Otherwise, sodium carbonate is colorless. Stand the conical flask on a white tile. There should be a white tile below it. जो मैंने ब्लैक बनाया है actually, This is white tile. Why white tile?
To see the titration properly.
Yes, because color is very light. So in white background, it can be the observation is made clear. Slowly add sodium chloride from the burette into the conical flask. Okay, then we will put uh, both of them in a way that compatibly we can add content of the burette into the conical flask. Slowly add dilute hydrochloric acid A from the burette to the conical flask while swirling. Swirling and shaking has minor differences. When you are swirling means moving in a way in round way, and shaking is this, and swirling is like this. You will keep hold it from here and move it in circle. This is called swirling. While swirling the flask until the solution becomes orange. Orange, orange means when you will add, then you will get orange color over here. Because here it was yellow, so on adding acid, there would be the color red. Methyl orange has red color in acid. So red and yellow combine together to form orange when there is an equivalency until the solution becomes orange. Record the final burette reading. और फिर आप वहां पे क्या करेंगे finally? Suppose if you have started from here point point 4 and you ended at 23.2. So the final reading would be 23.2 minus 0.4. So it would be
22.8.
22.8. But actually, the exact reading is given over there. So it was experiment number 1. And how does they perform experiment number 2? So another student or the same student perform experiment number 2. He refilled the burette with this, run some of the dilute hydrochloric acid out of the burette so that the level, the same thing is here. We have done the same thing here. But
Mhm.
here he doesn't wash. Why?
Because it already has the acid you need.
Yes, same kind of acid with the same concentration. If it is from the same flask, so it means it is the same, so we don't need to wash or rinse. Okay.
B.
Okay. So next, but empty the conical flask and rinse it with distilled water. We washed it and we rinsed it with distilled water. It was necessary because there was some other chemicals. And again,
Yes.
we using the measuring cylinder, we add the same quantity of sodium carbonate, aqueous sodium carbonate, and again five. But here we use the 5 drops of thymophthalene indicator. Indicator has been changed here. Okay. So in both of the experiment, the change is only the indicator. And then he performed the same experiment and until the solution becomes colorless. So what should be the color in base? So remember that thymophthalene is thymophthalene. I'm writing it TH. It is, oh, not yellow, sorry. It is blue in base. blue in base, while in neutral and acidic solution, it is colorless. Okay. Now they have repeated the experiment number one, means using methyl orange with solution B instead of hydrochloric acid A. Okay, got it? So we
G.
should keep these experiment in our mind if we are going to solve the question regarding these three experiments. So the question starts from here. Use the Buret diagrams in figure 2.1, figure 2.2, and figure 2.3 to record the reading for experiment. So here you can see that it was the initial reading. So initial reading was, this is 0.8 because 5, 6, 7, 8. And it is 26.2. Got it?
D.
So we will write it here. In experiment 1, the final Buret reading was 26.2 and it was 0.8. And now you tell me for the second one.
So initial reading would be 0.2 and final reading would be 12.9.
12.9. Yes, you're right. It is 0.2 and it is 12.9. Correct. So 12.9 and 0.2. Now see next one, number 3. So this is 39.1 and it is exactly 1.0. Okay. Mention one decimal place.
G.
So initial was 1.0 and final was 39.1. Okay. So the volume of dilute
G.
hydrochloric acid added or consumed, uh, you can subtract the initial reading from the final reading. So it would be zero point 0.4 and 25.4. Am I right?
G.
And here 12.7 and here I think I have made a mistake here. It is 38.1. It should be 39.1 and it should be 1.0. Okay, got it? Now come to the next part. So now state which solution of the dilute hydrochloric acid A and B is more concentrated. Which one is more concentrated? Yes. See, experiment 1 was carried out with solution A, 2 was also carried out with solution A, and it was carried out with solution B.
B. So I'll say experiment A.
Experiment yani HCl-A. Okay,
G.
so A is more concentrated, that because in experiment number 1, less volume of HCl is consumed. Did you know how many times more concentrated this solution of dilute hydrochloric acid is than the other solution of dilute hydrochloric acid? So one was 38.1 and another was 25.4.
So
Yes. So we can do this by dividing the volume consumed in experiment number 3, that is 38.1, by the volume consumed in experiment number 1, that is 25.4. So this answer is 1.5. So 1.5 times A is 1.5 times more concentrated than B. Okay. Yes. Compare the volume of hydrochloric acid A used in experiment 1 to the volume of dilute hydrochloric acid A using in experiment number 2. So when we are doing such questions, then better to see the result, the volume consumed. One was 12.7 and another was 25.4. So in experiment 1, it was 25.4, and in experiment number 2, it was 12.7. Now again, do the same thing, 25.4 divided by 12.7, and now calculate it. So first we will see that greater volume of A is used as compared to B, and it is double. Okay,
Okay.
it is by the factor 2, or you can write it is doubled. Okay, okay. Deduce the volume of dilute hydrochloric acid B required to reach the end point if experiment 3 is repeated using thymophthalein indicator. So think about this. This experiment was carried out with methyl orange. It is also carried out with methyl orange, and it was carried out by thymophthalein blue. So with thymophthalein, there is a double volume that is consumed here. So how much volume would be consumed here if this experiment, sorry, the experiment number 2 is carried out? Uh, no, no. If this experiment number 3 is carried out with thymophthalein instead of methyl orange. See, this experiment was performed with solution HClA. This solution was also performed by HClA, and this solution was performed by HClB.
HClB.
So this is performed by HClB. What is the difference in between these two? Base is
They,
same, base is same,
yes.
but only indicator is different. And here
G.
we performed this experiment with the acid B, but with the same base. Base is same in all the 3 experiments. So they are asking perform experiment number 4, and without performing experiment number 4, you just change methyl orange with thymophthalein blue. Use thymophthalein here. So what should be the final result here? How much volume of HCl would be consumed for solution HClB? In this experiment with methyl orange, it was 38.1. See, what is the difference between these two experiment? Only the thymophylline and methyl orange. So the same
जी
difference is here. So here, when you use thymophylline blue, then half of the acid was consumed. So if
जी
you are repeating the same experiment, so definitely half of this would be consumed. So if it was 38.1, so
so
divided,
19.5
yeah, exactly 38.1 divided by 2. So that would be the answer. So 38.1 divided by 2,
19.05 do we round it or
19.05,
no?
or you can leave it as it is. Okay,
Okay.
but better to write
जी
complete answer. So it would be 19.05 or 19.1. Okay, because when you will round it off, on rounding off, it becomes 1. And must mention the unit. Okay, this is page number 8 and part D of this question. At the start of experiment 3, the burette is rinsed with distilled water and with dilute hydrochloric acid B. Identify the substance removed from the burette when it is rinsed with distilled water at the start of experiment 3. जब आपने एक्सपेरिमेंट 3 शुरू किया था, तो उससे पहले उसमें क्या यूज किया था? हमने बेसिकली उसको ही रिमूव किया होगा ना? सोचें।
हाइड्रोक्लोरिक एसिड
कौन सा वाला?
ए
सही, क्योंकि एक्सपेरिमेंट 3 में हाइड्रोक्लोरिक एसिड ए यूज किया गया था। ए और बी दो, एक्सपेरिमेंट 1 एंड 2 दोनों में। तो जब 3 हमने स्टार्ट किया और वहां पे हमें HCl बी यूज करना था, तो फिर हमें उसको रिमूव करना है। सो वी वुड राइट दिस। सो दिस इज HClA. Describe how the result of the titration would change if the burette was not rinsed with dilute hydrochloric acid B. See, this was the burette. Okay,
जी
and you performed first an experiment with HClB, HClA, sorry. It was performed with HClA. Then what happened? You use water, distilled water, to wash it. So the any particle of acid that would be there, it would be washed out. So no A would be there after washing. सही ना?
जी
तो ए से, जब आप ए को, जब आपने यानी परफॉर्म एक्सपेरिमेंट परफॉर्म करने के बाद वाटर से वॉश कर लिया, तो अब यहाँ पर एसिड तो नहीं होगा, बट drops of water would be there. So when you will add B, so water would, uh, the water drops which are there with the inner wall of the burette, they will lower the concentration of B further. यानी ये बी की कॉन्सेंट्रेशन को मजीद डिक्रीज कर देंगे। तो जब बी की कॉन्सेंट्रेशन मजीद डिक्रीज हो जाएगी, तो डेफिनेटली फिर वो ज्यादा वॉल्यूम कंज्यूम होगा ना फिर उसका। लार्जर और द ग्रेटर वॉल्यूम ऑफ acid B would be used. Explain why the conical flask is not rinsed with aqueous sodium carbonate. I have told you earlier that we never rinse the sodium, never rinse conical flask with the solution that would be added to the flask. यानी सोडियम कार्बोनेट को आपको उस फ्लास्क में लेना है, तो उसको सोडियम कार्बोनेट से वॉश, वाटर से वॉश करने के बाद उसे रिंस नहीं करेंगे हम। क्यों नहीं करेंगे, रीजन बताइए। Yeah, अगर हम इसको रिंस कर लेंगे, then some of the drops would remain with the wall of the container, and then we add 25 centimeter cube. So definitely it would be slightly greater than 25 centimeter cube. So
जी.
it will increase.
The volume.
Yes. So it will increase the volume of sodium carbonate solution. Okay.
जी.
Okay. Now component E. Explain why a white tile is used during the titration. We have already explained this. To see the color change easily. Next. Describe the effect of result of warming the aqueous sodium carbonate used in experiment number one. Even not only for experiment number one, if you are heating the flask in any one of the experiment that we have described, even even if it may evaporate water, if then the effect would be none, because number of moles remains the same, because number of moles of sodium carbonate would not change. Okay.